The binary number system.
So, a binary number system means that there are only two digits or two characters that are used in the system. So, which is 1 and 0. And so traditionally our like a 10 would be represented as like this, and this would be like 20. It doesn't work like that in a binary system. How a binary system works is that you go, like in this place it would be a 1 would represent a 1. Pretty simple. But next place, each time you go up, it's a multiple of 2. So for example, if there's a 1 here, that means, and there's a 0 here, that means it's 2. Now, if we go up one digit, that if there's 2 zeros here, that means it's and there's a 1 here, that means it's a 4. So we can go so on, so on. So let's just write a number here so that this is 1, let's say this is 0, this is 1, this is 0, and this is 1. And this would be 21 because there's no characters here. We just skip those. But this is a 1, so this just represents a 1. This is a 1 here, so that represents a 4. And this is a 1 here, so that represents a 16. So we just add those all together. But the thing you really have to remember is each time there's a new place, like kind of like 10 or something, each time there's a new place, it's a new multiple of 2.
Okay, so today we're going to be learning the binary number system. The first thing that you're going to want to know is that it has two different symbols, 0 and 1. 0 means off and 1 means on. So generally, binary code consists of 8 digits. So for example, you could go 0, 1, 1, 0, 1. This would mean off, on, off, on, off, off, off. So this is a 1, this is a 2, this is a 4, this is an 8, 16. So 8 is the only digit that is on. So this 1 means that there's going to be 8. So another example would be 0, 1, 1, 0, 0, 1, 1, 0. So you're going to start 1, 2, 4, 8, and 16. Since there's two 1s, 2 and 4 are on, so this is going to mean a 6. And these translate to letters in the alphabet. So the 8th letter in the alphabet is going to be an H, and the 6th letter in the alphabet is going to be a F. Okay, so when translating binary numbers to the alphabet, you just use the number that's on. So say this is 8, that's going to be an H, because H is the 8th letter in the alphabet. If we refer to this chart, we can see that H has 0, 1, 0, 0, 1. And so this would be 1, 2, 4, 8. This 1 is on, so that means 8. So that's why that's an H, because that's the 8th letter in the alphabet. So the first 4 digits in a set of binary numbers could be either 0, 0, 1, 1, which means it's a number, 0, 1, 0, 0, which means it is a uppercase letter, 0, 1, 1, 0 means it's a lowercase letter. When we head into letters that are higher than 8, this number may change. So for example, if the character is, say, a Z, the starting number is going to be 0, 1, 0, 1. Because in order to get to Z in the alphabet, which is the last letter, we need to use this at 16. So that's going to, since it's the first set, say there's a 1, 0, 1, 0. That would be Z, because it would be 1, 2, 4, 8, 16. So the numbers that are on are 16, 8, and 2. So O, the letter O is going to be, and then 1, 1, 1, 1. O is the last letter in the alphabet that can be read with binary with the last 4 digits. After O, for like P, Q, R, S, T, U, V, W, X, Y, and Z, you're going to have to use this extra number, because in order to get to 26, you need this 16. So that's why when I used Z, this 1 is here, because if you only used the 8 and the 2, that would only be 10, and Z is definitely not the 10th letter in the alphabet. But when you use this 10 and then also the 16 from the first 4, that's going to make 26, which is Z. And then this is O, and O is the last letter that uses 1, 2, 4, and 8.
So we're gonna do an example for the binary numbers. In this case, this first part of the 8 digits tells you that it's gonna be a uppercase letter. So always remember that this code tells you that it's uppercase. This tells you that it's lowercase. So this letter, the one that it's in this 8 numbers, is gonna be lowercase. That's gonna be uppercase. So this one has the same pattern as that one, so it's gonna be lowercase, and this one has the same, so it's going to be lowercase. So how to actually put the letters in and know what word we're talking about, you actually just got to follow this pattern. It's always the same, and it starts on the right side. So it's 1, 2, 4, 8, 16. So in this case, we have 1, 2, 4, 8, and then we count those, only the ones that have 1 underneath. So in this case, we have 1, 5, and then that's 13. And the 13th letter of the alphabet is the M, so we write it down. Then here, we only have 1, 1, 1. So the first letter of the alphabet, which is A. Then in this case, we have nothing, nothing. We have a 4, and then we have a 16, the 28th letter in the alphabet, which is the T. Then the last part of the problem, we have only like one letter with one number with 1, 1. So it's the 8th letter, which in this case is the H. And that's basically how you read it and how you solve the problem.
So after explaining the whole how you convert from alphabetical units to binary, or to binary to alphabetical, we're now going to explain how it works in the same way, well, in a similar way, but with decimal numbers. Now the first thing that you need to focus is, well, we have this whole the bunch of digits in binary here. The first thing that you need to notice is that these 4 digits, this represents that it's going to be a number. That is the main difference between the decimal and alphabetical. Now the next 4 digits that you have here, and well, in the other ones, is going to represent the number that is going to be in decimal. So for example, here we have it starts with 1, 2, 4, and 8. It doesn't go to 16 because it is not necessary. So here we have, we only count 1, so we have 2. We have the first translated number, 2. Now we go to the second row of 8 digits, and we notice again it's still a decimal number, and we have these 4 zeros. Again, it will be 1, 2, 4, and 8. Since we don't have any 1, then we don't count it, and we just count it as a 0. Then we go to the third row. We again notice that this is for decimal numbers. And then we go here and we see that we only have 1, 1. And then that means that when we put it here, 1, 2, 4, and 8 is going to be only 1. Then the next translated line is going to be just 1. And then in the next line, again the same, meaning that it's going to be a decimal. And then we got 0, 1, 1, 1. We put again the way to translate, that is a 1, 2, 4, and 8. And we just count 1 plus 2, 3 plus 4 is going to be 7. So this whole row of binary numbers is going to mean 2017.